drone mimics albatross flight for endless energy-efficient soaring. What if drones could fly like birds? Not just any birds, but the masters of the skies. That's the bold vision behind a groundbreaking project led by University of Cincinnati Assistant Professor Sameh Eisa. His team is drawing inspiration from the majestic albatross, a seabird known for its astonishing ability to glide across oceans for days without flapping its wings. But here's where it gets controversial. Can machines truly replicate nature's most elegant solutions? Albatrosses, with their impressive 11-foot wingspans, have long fascinated scientists. Their secret weapon? A flight technique called dynamic soaring, which allows them to ride wind currents with minimal energy. Eisa, an applied mathematician, is now translating this natural marvel into cutting-edge drone technology. Backed by a $700,000 grant from the Defense Advanced Research Projects Agency, DARPA, his research aims to revolutionize unmanned aerial vehicles, UAVs, through biomimicry, engineering inspired by nature. But this is the part most people miss. It's not just about big wings. Albatrosses possess an uncanny ability to sense wind through their nostrils, adjusting their flight path with precision. Eisa's team is mimicking this sensory finesse to create drones that can autonomously adapt to changing wind conditions in real time. To do this, they've developed a novel flight control system dubbed a natural extremum seeking system. This approach allows drones to continuously seek the most efficient pitch, yaw, roll, and airspeed, just like the birds do. Imagine a sailboat tacking into the wind. Albatrosses climb into faster air currents, then dive and turn, using gravity and wind to propel themselves forward. They repeat this cycle endlessly, skimming just inches above the water, all without a single wing beat. They're solving an optimization problem that's mind-bogglingly complex, Eisa explains. And they do it effortlessly. In simulations, Eisa found that even advanced computers struggle to match the albatross's real-time decision-making. A few seconds of flight data can take over a minute to process. Yet these birds do it instantly. That's why replicating their abilities in drones is both a technical challenge and a scientific marvel. Here's the twist. Wind, traditionally seen as a nuisance for drones, is being reimagined as an asset. Eisa's team, in collaboration with MIT and industry experts, is working to flip the script, turning wind from foe to friend. Their project, aptly named Albatross, is testing new flight control designs that could dramatically reduce energy consumption in UAVs. And the implications go far beyond engineering. If successful, this research could reshape our understanding of flight in biology and physics. It might even validate the theory that dynamic soaring is nature's own extremum-seeking system, a concept that could spark debate among scientists. UC Associate Dean Gautam Pillai sees this as more than just a technical breakthrough. We're addressing national defense priorities like endurance and adaptability in contested environments, he says. Plus, UC students are gaining hands-on experience at the forefront of aerospace innovation. Eisa's passion for flight runs deep. In the classic debate, invisibility or flight, he always chooses flight. It's something we yearn for because we can't do it, he says. That's why biomimicry is such a powerful tool. Nature has spent millions of years perfecting flight, and now engineers are finally catching up. But what do you think? Can drones ever truly match the elegance and efficiency of a bird in flight? Or is nature's design simply too complex to replicate? Drop your thoughts in the comments, and let's see where this conversation soars. Unraveling the secrets of albatross flight, a UC engineer's mission. Imagine soaring through the skies like an albatross, effortlessly gliding for days without a single flap of your wings. It's not just their size that makes these birds expert flyers, but their extraordinary ability to interact with wind and gravity in ways we're only beginning to understand. Now, a team of researchers at the University of Cincinnati, led by aerospace engineering professor Sameh Eisa, is on a mission to replicate this natural marvel in the world of drones. With a generous $700,000 grant from the Defense Advanced Research Projects Agency, DARPA, Eisa and his collaborators are delving into the fascinating world of biomimicry, engineering inspired by nature. Their goal? To replicate the albatross's energy-saving flight technique known as dynamic soaring. This technique allows the birds to extract energy from wind currents as they alternate between climbing into stronger winds and gliding downward to gain speed. Eisa's team has developed a novel approach that mirrors this behavior, calling it a natural extremum-seeking system. It's based on how albatrosses and drones modeled after them identify the minimum and maximum values of pitch, yaw, roll, and airspeed to maintain optimal efficiency. This process is akin to sailing, where the birds tack into the wind to climb and find stronger currents, then dive, converting that energy into speed. At the bottom of their arc, often just skimming the ocean's surface, they turn back into the wind and repeat the process, all without a single wing beat. But albatrosses' wings aren't the only secret to their success. Albatrosses literally have a nose for wind, Eisa adds. These birds can sense subtle shifts in wind speed and direction through their highly sensitive nostrils, allowing them to fine-tune their movements and maximize efficiency on both the ascent and descent of each soaring cycle. Eisa's analysis reveals that the energy albatrosses extract from the wind effectively offsets what is typically lost in flight, resulting in a nearly constant total energy throughout each dynamic soaring cycle. This remarkable efficiency has long been reflected in literature and folklore, with sailors once seeing albatrosses as omens of favorable winds. But replicating this gift from nature in autonomous drones is no easy task. Eisa's team is working alongside researchers from industry, meteorology, and MIT on a DARPA-backed initiative called Project Albatross. They are designing new real-time flight controls that mimic how albatrosses fly, constantly measuring changing wind speeds and directions, then calculating the ideal angle of attack and rolling action to make flight control adjustments in real time. If we can get closer to how the albatross does it, we can be more efficient, Eisa explains. By unlocking the secrets of dynamic soaring, we're not just advancing unmanned aerial vehicle efficiency, we're addressing critical national defense priorities, such as endurance and adaptability in contested environments. This project offers valuable opportunities for students, giving them hands-on experience with research that could significantly impact the aerospace industry. The project will give UC students a fantastic opportunity to work on a project with profound implications for the aerospace industry, says Gautam Pillai, Associate Dean of Research at the University of Cincinnati. Just as importantly, students will get unparalleled experiential learning opportunities, placing them at the heart of cutting-edge research where theory meets real-world application, in collaboration with top-tier institutions and industry partners. For Eisa, the fascination with flight runs deep. Nature has been optimizing flight for millions of years of evolution, he says. So, to take this gift from nature and make it available to humanity is engineering at its best. As we delve deeper into the mysteries of albatross flight, we're not just pushing the boundaries of drone technology, we're unlocking the secrets of nature's most efficient flyers. And this is the part most people miss. While we're learning from albatrosses, are we also poised to surpass them? Can human ingenuity and technology eventually outdo nature's most efficient flyers? Or will we forever be in awe of these magnificent birds? Let's discuss in the comments below. Source: UC Aerospace engineer reveals albatross's wing mastery. Ride the wind. Revolutionary Albatross-Inspired drone for endless flights. Imagine a world where drones can soar like majestic albatrosses, harnessing the power of the wind for longer, more efficient flights. This is the ambitious vision of UC Assistant Professor Sameh Eisa and his team. Inspired by the graceful flight of these birds, they aim to revolutionize drone technology with a biomimicry approach. Albatrosses, with their impressive 11-foot wingspans, have mastered the art of dynamic soaring. By utilizing wind currents and gravity, they can glide for hours without flapping their wings. Professor Eisa is fascinated by this natural phenomenon and believes it holds the key to enhancing drone capabilities. They use it skillfully. It's the only way they can sustain such long flights, Eisa explains. GPS trackers reveal that albatrosses can cover hundreds of miles each week, and by the end of their lives, they've flown a distance equivalent to 20 times the Earth-Moon distance. But here's where it gets controversial. Eisa and his team have developed a system that mimics this dynamic soaring principle, calling it a natural extremum-seeking system. They plan to use this system to design new flight controls for drones, allowing them to mimic the albatross's flying style in real time. Albatrosses also possess a sensitive nose, which enables them to make precise flight adjustments. Eisa has tested their navigation abilities in simulations. And even advanced computers couldn't plan a better flight path in real time. They are solving an optimization problem that is unbelievably complicated, he says. It seems implausible that they can do it with such accuracy in real time. So the challenge is clear. Can drones be engineered to fly like albatrosses? Eisa believes that by understanding and replicating this natural phenomenon, drones can become more energy efficient. With a $700K grant from the Defense Advanced Research Projects Agency, they aim to prove just that. Nature has been optimizing flight for millions of years of evolution, Eisa adds. It's an incredible gift, and we want to make it available to humanity through engineering. What do you think? Can drones truly harness the wind like albatrosses? Let's discuss in the comments and explore the possibilities of this innovative project.